So I got this idea of a voltage, current, power meter and logger from GreatScott and his video, but I wanted to do a few better. So this is sort of what the end product looks like, at least the custom-made PCB that I did. You can see it has an outline for ESP32, a couple of LED lights for indicators, two INA 219s, two OLEDs, and just some extra 5-volt and 3-volt inputs. Here's the power supply where the board will be powered from. And here is micro USB for power input, type A for USB power output, and then I also made a terminal block here for just connecting wires if you wanted to sense the voltage, current, and power VCP through that. Also have integrated two fuses, 3 amp fuses for protection, some capacitors if it was needed on the output to stabilize the voltage, input select switch, so either USB or the terminal, so you have the option to switch from either the two USB inputs and outputs or just the terminal output. And the V plus would be the voltage in, V minus voltage out, and of course the ground. And also the two INA 219s, one is programmed for the 400 milliampere hour resolution, or I should say sensitivity, and the second INA 219 is for the 2 amp, the full range. So depending on how much your project draws will determine which one you would select there. Also have an SD card module for a reader. Two buttons. One is a board reset. The other one is a set refresh rate, which I'll get into. I have a slide switch to turn the power on and off for this SD module. If you don't want to log the data, you can always turn that switch off. And there is the voltage, current, power, logic select button, whether you want the 400 milliampere hour or the 2 amp, the full range. This pot here goes back to A2 on the ESP32, and that's a Adafruit feather, Adafruit feather size. I can't think of the word. I can't think of the word, but yeah. So that's where that goes to, and basically that will determine how quick the samples are for data logging. So, and you gotta excuse my very amateuristic video here, since I don't have any fancy equipment or anything. This is right on my Samsung Galaxy S7, and I'm just holding it. I don't even have a stand. But I was debating on whether to do this video or not. If anyone would find this useful, then I guess it's worth it. So here's the front of the board. Here's the back. Try and get the... There we go. So anyway, I will show you what this board, this was from JLC PCB. They were absolutely excellent in the software, the Easy EDA software, and the JLC PCB actually made. I made one mistake on this board, and you can see it right there. That was the, those two lines are not supposed to cross, so I had to etch them out. The A2 sensing from the potentiometer back to the ESP32 was crossed with 5 volts, so not good. After I burned through a couple of pots, I realized that I had to etch out those two sides to disconnect. So anyway, going to show you the actual finished product. Alright, so yeah, so I actually used female headers. I was debating on whether I wanted to do this, but I figured it's a lot easier to solder female headers and then to pull the resistors, LEDs. If I need to change them out, it's a lot easier than desoldering. So let me zoom out here. Got a nice box. It's fit pretty snugly. clear top so you can see that was sort of the plan. And there's the micro SD slot. Here's the pot going back to A2 to determine the sampling rate. Slider switches, I had to do 2 of them. Nothing is labeled here, so it's sort of like not totally finished, but I know what it all does. There's the cutout, and again, I don't have a 3D printer, so this was me, my rotary tool. Micro USB, power in, power out, and then there's the terminal block, so you have those 2 options, and here's the selector for depending on which one you want. There's how we're going to power the board, and let's get started. One more look from the top. Yes, you can see the fuses in there. And there's the ESP32 feather. Alright, so we're going to turn it on using this little plastic piece. So hit the little button there. And you can see that white light is blinking. I can hit the refresh button, the reset button. Sorry about that. And again, the white light blinks until you set the refresh rate. So here I'm going to turn the pot, and you can see, depending on the value that I move, see at 250. So I have this in the program, 500 milliseconds refresh rate. 0 milliseconds basically means as fast as it can go, which I found to be about 150 milliseconds between each reading. So then I have 250, 500, 1 second, 2 seconds. Sorry for the bad lighting here. Apologize. 10 seconds, 20, 30, 40, 50, 60. So up to 1 minute sampling. So we're going to do 500 milliseconds. Why not? So here you would come over to this button and say set refresh rate. So when that happens, you'll get the red, which means that you're using the 2 amp. You can kind of see the rating there. The 2 amp selector versus the 400 milliampere hour, so 400 milliamp. So the green light blinking once a second means that it's actually writing to the SD card, so that's confirmation that that's working. So I'm going to use my electronic load and put this to the test, and here's a battery bank, so stand by while I hook this up. Okay, so here's my little electronic load that I have going through. So this is measuring the voltage and the current, as well as the milliwatts of power that's going from the battery bank that's powering this load. And let me see if I can increase it a little bit there. I'm increasing it. 0.5 amp. You can see the voltage drop a little bit on the battery bank. So it's saying like it's like 0.48, and the little Chinese one says 0.46. Pretty close. Let's keep going. Up to 1 amp. Again, we're still logging the data. 1.02, 1.03, and here we're getting 1.03, so that's looking good. 4.36 on the volts. So, and this is not fully charged, but if it was probably fully charged, the voltage would be a little bit higher, but that's a pretty good voltage drop for 1 amp. So we'll dial it back. Let's see how much we can go here before the voltage cuts off. It's like 1.1 amps. Try and get the lighting right. 1.09. This fan is really noisy. Unfortunately, this fan is always on. Something wrong with that sensor. But anyway, this is working really nice. I'm just going to slowly dial it back down. $100 milliamps, and I think that's the lowest it goes. So, again, refresh rate's only set to 500 milliseconds. So, all right, we are going to power this off and check out the data on the computer. All right, we're at my computer, and this is the text file that it creates. It's called VCP.text, voltage, current, power. And you can see it has the time in milliseconds elapsed. The gain that was set, that was from that switch. We were using the 2 amp range, but if you're using the 400 milliamp range, that would be printed here. ID numbers, so this is just a sequential for the number of records. Bus voltage, shunt, load voltage, current, milliampere, and low power, so that goes all the way down. So when you plop that into Excel, looks something like this. Yeah, so the flat line here at 500 milliseconds just mean that there was no missed samples. Everything looks good. Here is the current and the power, so you can see as I was moving the electronic load from 0, this is in milliamps here, going up to about 100, was turning it up, and we were up to about, and here's the currents in blue, power is in red. So here's where we stepped it up to about 500, and then we brought it up to about 1.1, which is up here, and then back down, back up. You guys get the picture. Here's a picture of just the current graph and the power graph. I'm a meteorologist, I'm a bit of a data freak, so this is kind of cool to be able to have this type of data, know what the current and power draw is for your project, and then you can calculate how big of a battery you need. I think that's very, very useful, and again, it was very, very simple to do. The hardest part was making the PCB, and because the program is pretty straightforward. So we'll take a look at the program. Using the Adafruit library for the OLED, as well as the INA 219 to find some of the LED pins. SD card pin. Set up the serial. If anyone is interested, you can leave a comment, and I'll go ahead and give you this, give you the code if you're interested. There's printing the header on the SD card. So here we're going to call a function get refresh rate, and then we're going to refresh the rate, display that refresh rate. So go down to that, set the refresh rate, get refresh rate. So here it's going to actually, here's where it's reading that pot value. I'm just using the map function to give it a new range, but basically it's returning 0, which again is 0 millisecond delay, which is as fast as this thing can go, which is about 150, quarter of a second, half a second. So it's just looking for ranges between these values on the analog input. And then it's going to store the previous pot value equal to the new pot value, and then we're going to update the refresh display with that value. And then it's just a matter of in the loop get the time in millis. I'll let you guys read this. There's your voltage, current, power variables, and then it's printing it here to the SD card. Here's the VCP.txt file that we're creating with all the variables separated by commas. And here we're actually updating the display with those same values. So that's pretty much it. Here is an example. This is a much longer example. You can see there's a lot more data starting at about 35. Let's see, focus 33 seconds. Sorry, I'm just holding the camera here. I'm doing the best I can. All the way down. So it's quite a bit of rows here. 51,000 rows. There's the number of records. 51,211 records. As I was charging my Samsung Galaxy S3, it's my old phone, and you can see here, once in a while you'll get a few blips. I was doing this at 250 millisecond refresh rate, so once in a while, this could be because of the PCB, I'm not 100% sure why, but anyway, it's not perfect, but it's pretty good. Here is the charging curve. Well, actually, we'll just look at the current. It's easy to look at. For my Samsung Galaxy S3, you can see it starts at about 438 milliamps, and then it slowly drops off. And yeah, it seems like every so often the current peaks and then comes back down. I'm guessing that's to keep the power supply on so it doesn't shut off. That's my theory. Here's the power, and actually you can calculate. I put a little formula here in Excel where you can calculate from the collected variables what the actual battery capacity is in milliampere hours and the power capacity of the battery. So if you drain your battery pretty much all the way and you charge it while it's logging to this SD card, plop data in here and you can actually get the actual capacity of the battery, which I think is pretty cool. You can test to see how good your battery is. So yeah, there's a few applications. I think it's pretty powerful that you can log it. And again, here's one more look at our example that we did. And that's it. So if you have any comments, please leave them below. Hope you enjoyed this video. And again, I apologize for the very amateuristic videoing here, but I want to actually get this video out. Alright guys, later.